Hey there, it's me, Miss B. And in this video, we're looking at the Unit 2, Lesson 1 cumulative practice problems from Illustrative Math Algebra 1. So, looking at our first question here, we have the videography team entering a contest and winning a monetary prize of $1,350. So, which expression represents how much each person would get if there was X number of people on the team? Okay, so we are choosing what we get here. So we're going to take that 1,350, and the idea is that we're splitting it by the number of people on the team. So in that case, this means we are dividing. So we are going to choose A. We are dividing among team members. So we're not going to be adding or subtracting or anything like that. We need to use X because we don't know how many team members there are. So for question 2, we have some matching going on here. So to support a local senior citizen center, a student club sent a flyer home to the N number of students in the school. And the flyer said, please bring in money to support the senior citizen center. Paper money and coins are accepted. And their goal is to raise T number of dollars. So we're going to try to match each quantity to an expression, or an equation or an inequality that describes it. So basically, we're going to select something from A, B, C, D, and E and match them all with 1, 2, 3, 4, or 5. So they said T is dollar. I'm going to highlight some important parts here. T is the amount of dollars they're trying to raise total. N is the number of students in the school. Okay. So we're going to read each description and then try to match it. So this first one here says the dollar amount if they want to reach half of their goal. Well, their goal is T. So half of that would be 0.5 times T. So A is going to go with 2. Since they're pretty close here, I'm just going to write the number next to the situation that matches it. The dollar amount they would have if every student donated 50 cents. So this would be the number of students, which is N, and then we would multiply that by the 50 cents. So that is going to be this one here, 50 cents multiplied by every student that is at the school. So number 4 goes with B. C is the dollar amount the club could donate if they made $50 more than their goal. So if it's $50 more, that means we're going to use option 1 up here, which is their original goal plus 50. So that one matches here. And we have 2 more. We're still going to match them both, and we're going to double check that they both work, even though we should have 1 left at the end. So dollar amount at the club would still need to raise after every student donated 50 cents. So it's goal after every student donated 50 cents. When we know every student donating 50 cents was this, and we know the goal was T, so that goal minus that is going to be this one right here. So this would be 5. The goal minus 50 cents for each one. And we're going to double check that E works with choice number 3. Dollar amount the club would have if half of the students at the school each gave 50 cents. So this one's less obvious, but this is 1/2 of 0.5 N. They just multiplied those pieces together. So E is number 3. Which brings us to question 3. So it's near the bottom of my page, which means I can't really scroll up. So forgive me for writing on the lower part of the screen here. Excuse me. All right, each of the 10 students in the baking club made 2 chocolate cakes for a fundraiser, and they all used the same recipe with C cups of flour in total. We want to write an expression that represents the amount of flour required for one cake. Now, I don't think, there is nothing left here. I just wanted to make sure part of this question wasn't on the next page. Each of the 10 students, each of them made 2 chocolate cakes, which is 20 total. So that's a big goof here. We want to take 20 total cakes and say C divided by 20. That is much better. Okay, yes. I misread that at first. I thought that the 10 students made 2 chocolate cakes, but they each made 2 cakes. So that gives us 20. I thought it was like, I don't know, people working together. So sorry about that one if there was a little confusion there. Let's look at number 4. A student club started a fundraising effort to support animal rescue organizations, and the club sent an information flyer home to the students, N number of students in the school, and it says they want to raise T dollars. Donations, any amount. Their goal is to raise T dollars and to donate to a cat shelter and a dog shelter. So match each quantity to an expression, equation, or inequality that describes it. We are going to do the same thing we did as the question on the other page. So the dollar amount the club would have if they reached 1/4 of their goal. So 1/4 of their goal is 1/4 T, so that would be option 2. The dollar amount they would have if everyone donated a quarter, well, 1/4 is going to be 25 cents, but in this case, we're still using fractions, so that is going to be 1/4 N. That's going to be number 5 here. We would multiply that by every student in the school, and that would give us that amount. Okay, the dollar amount they could donate to a cat shelter if they reached their goal and gave a quarter of the total donation to a dog shelter. So they reached their goal, and then they're giving 1/4 to a dog shelter. Well, that means we should have 3/4 of the goal amount left. So this is going to be number 4, which is 3/4 of T, and then they could give 3/4 to the cat shelter. Okay, D is the dollar amount they would still need to raise to reach their goal after everyone donated a quarter. So it's going to be the total goal, and then except for that 1/4 from everyone that we had in option 5, right? So it's the goal minus that, and that is number 3. Which means number 1 should match up with this one, but we're still going to double check our amounts. If 3/4 of the students gave 50 cents, so 3/4 of the students, and then 1/2 as in half of a dollar. So yes, this one is going to match up as well. And I forgot to cross out number 3 here. So yes, number 1 is going to match with E. Because that 1/2 is like half dollar. For number 5, we have a softball team ordering pizza to eat after their tournament. They want to order cheese pizzas that cost $6 and 4 topping pizzas that cost 10. They want to order, or they order C, number of cheese pizzas, and F, number of 4 topping pizzas. What is going to represent the total cost of all the pizzas they order? So if these are the number of pizzas, we also need to multiply them by their price. So the total cost is going to be 6C plus 10F, because it is $6 for every cheese pizza and 10 for every 4 topping pizza. So to set that up, we would have 6C plus 10F. Now we are also including, and I know I said only Unit 1 or Unit 2 Lesson 1 at the beginning. I'm also including Unit 2 Lesson 2 in this video because our plan is to assign these things on the same night. So sorry if your homework assignment is a little bit long, but I'm going to do Unit 2 Lesson 1 and 2 in this video. So this is the start of the Lesson 2 content. Large cheese pizzas cost $5 each, and large one-topping pizzas cost $6 each. Write an equation that represents the total cost T of C large pizzas and D large one-topping pizzas. Okay, so my total cost is going to be equal to the dollar amount for each multiplied by the number of them. So $5 for every cheese pizza, and I'm going to combine that or add it to the $6 for every large one-topping pizza. And that would be my my equation. Which brings us to number 2. So Jada plans to serve milk and healthy cookies for a book club meeting. She's preparing 12 ounces of milk and 4 cookies per person. So including herself, there are 15 people. Oh, wow, and she's got some money and stuff going on here. So let's look at some of these pieces. I know 12 ounces of milk and 4 cookies per person might be important. There's 15 people in the club. I then also have 24 cookies and a cost of $4.50. And my milk jug is going to contain 128 ounces and cost $3. And then we have a couple different things here. N is the number of people in the club. M represents the ounces of milk. And then C is representing number of cookies. Oh my gosh, and B is representing Jada's budget in dollars. Okay, we got a lot of things happening here. That's why I have everything color-coded and annotated, and we are going to see what our quantities and constraints could be. So this first one potentially says the ounces of milk is 12 times 15. So am I going to have milk equals 12 ounces per person times 15 people? Yes, this would be one of our quantities or constraints, the quantity that we would want. For part B, or option B, they say 3m plus 4.5c equals B. Well, 3 would be the number of ounces of milk multiplied by 3, but it's $3 for 1 gallon and not the actual ounces of milk. So I'm going to say this is not quite it. They're getting close because they know that the milk costs $3 and that it's $4.50 for a package of cookies. However, these are the individual things and not the package types. Let's look at option C. This says 4 times n is equal to C. So n was the number of people in the club. And if it's 4 times the number of people equal to C, C was cookies. So 4 cookies times the number of people. Yep, that should be one of our descriptions of the number we're trying to meet. Now 4 times 450 equal to C. C is the number of cookies. The number of cookies is not going to be 4 times 450, so we're not going to use D. But we're potentially going to look at option E here. Well, actually, it said explain or show work for each letter, and I just started skipping over that. I know I was verbalizing it, but this is 4 cookies per person is kind of what this represents. Then for E, this is her budget. So 2 times 3. Well, she's going to need 12 times 15. So she's going to probably need 2 gallons of milk. Yep. Those are $3. And then 450 times 3. This is saying she would need 3 packages of cookies at $4.50 each. If it's 4 per person, she would do 24, means 6. Yeah, she would need 3 packages of cookies. So this would be accurate as well, because she would need 2 gallons of milk. Because she's preparing 12 ounces of milk for 15 people, we would do 12 times 15 to see the number of ounces we need. But I know that it's going to be larger than 128. So we know we're going to need a second gallon. And then this is adding on to that the 3 packages of cookies that she's going to need to buy, because they contain 24. So the number of cookies is what, 4 times 15. So that would be like 60. So yeah, going to need 3 packages of cookies. And that's what this one represents. Okay, so on to question 3. A student on the track team runs 45 minutes each day as part of her training. She begins her workout by running at a constant rate of 8 miles per hour for A minutes, and then slows to a constant rate of 7.5 miles per hour for B minutes. Which equation describes the relationship between the distance she runs and her running speed in miles per hour? Okay, so 45 minutes, 8 miles for A. Okay, so even though A is true, she is running for those minutes and they should add up to 45. We want the relationship that describes the distance she runs and her speed. So the basic relationship between distance here is that distance is equal to a rate times a time. We'll write it out, rate times time. And for us, the rate, this is speed. Since she has 2 different ones, we're probably going to have 2 things added up to that. So a rate times a time plus a second rate and another time should equal her total distance. So she begins her workout at a constant rate of 8 miles per hour. So her speed is 8 for A minutes. And then her other speed is 7.5 for B minutes. Now this is miles per hour. So that is the other tricky part here. Miles per hour. We're using time in terms of minutes. So we actually do need to look at this in hours. And so 1 minute, well, there are 60 minutes in 1 hour. So we would be taking her time, and we would be using these ones right here, C, or choice C, because we have to switch from our minutes into hours. So this is changing minutes to hours by dividing it by 60. So we have both the speeds multiplied by our time, but our time is also then changed into hours. And that's it for question 3. So if we keep going, we're going to have question 4 here, and this is Elena. She bikes 20 minutes each day for exercise. We want to write an equation to describe the relationship between her distance in miles and her biking speed in miles per hour. So when she bikes, okay, 20 minutes each day for exercise, her distance is going to equal, we need a rate times a time, but this is going to be in miles per hour. So her rate, but our time is in, we need it to be hours, but if she's saying 20 minutes, we're going to multiply this basically by 20 over 60. And that would be our relationship here. Now, if she's doing a constant speed of 15 and then 12 for the last 15, we can do this too. We can say her distance is going to equal the pieces added up. So 15 miles per hour for the first 5 minutes. So we have to do 5 over 60. And then 12 miles per hour for the last 15 minutes. So now we're changing this into less specific and more general terms. We don't know what her speed is, but we can say her distance is that constant speed of m for the first 5 minutes. So 5 over 60. These are multiplied. And we are then adding n miles last 15 over 60. So almost exactly the same as the one before it, but instead of knowing how fast, we now are just going to put a variable there because we're not sure how fast she's going to be going. Okay. So that brings us to question 5. A coach for the Little League baseball team is ordering trophies for the team. Players on the team are allowed to choose between 2 types. The gold baseball trophies cost $5.99, and the uniform baseball trophies cost $6.49. The team orders G gold baseball trophies and U uniform baseball trophies. Write an expression that could represent the total cost of all of the trophies. So I need to, I will just say that our cost is equal to the price of each, and then we're going to multiply that by however many we are ordering. So $5.99 was the cost of the G gold baseball trophies, but we're not just paying for the gold baseball ones, we're also paying for the uniform ones, so we are adding that onto our total. This is $6.49 for every uniform. So that is going to be our total cost, is those 2 numbers multiplied by the number of ones we are ordering. Question 6, we have functions r and d giving the height in feet of a toy rocket and a drone t seconds after they are released. And we're going to write some information about them in function notation. So at 3 seconds, the toy rocket is higher than the drone. So this is t in seconds, and it was d for drone and r for rocket. So we would say r of 3, the height of the rocket at 3 is higher than the drone, so it's going to be greater than the drone at 3. And then at the start, the toy rocket is 25 feet above the drone. So that's at the start, which is at 0 for our input value. So the rocket at 0 is, now it's 25 feet above the drone, so we're going to say the drone's height at 0 and then 25 feet up from there. And there we go. That's our function notation. So even though we could like try to read these numbers from our graphs, we don't need to, because they just wanted us to write out the statements and not to actually solve for what those numbers are. And that is it for these two, because then my next homework assignment here is for lesson 3. So thank you for sticking with me through this double assignment here for Unit 2, Lessons 1 and 2 of Illustrative Math, Algebra 1.